about a helicopter with contra-rotating blades like the new Mars helicopter, where both blades spin in opposite directions? This would counteract any rotor torque, but would also mean we need to build a gearbox and shaft system so that each propeller could spin in opposite directions, which isn't a problem for an electric aircraft, but because these air turbines can't produce much thrust. It's simple. I attach the turbine directly to a carbon fibre tail boom, and because the tail boom is hollow, if I seal off both ends, it can be pressurised. At the turbine end of the tube, I designed a three-way fitting that allows the incoming air to pressurise the tail boom, but also acts as a nozzle to power the turbine. Then at the other end of the tube, I can mount a 90-degree nozzle which will act as a tail rotor. With the propeller and air supply attached, I can spin the turbine and see how the torque compensation works. And it seems to be working better than I expected, so I need to reduce the diameter of the tail nozzle. But at least it seems to have enough thrust. I then printed a very basic rotor head which was inspired just attached to a pivot, and then a weighted stabiliser bar is attached at an offset angle. This stabiliser bar is very common on small scale helicopters, and the idea is that the gyroscopic stability of the bar will keep the helicopter level during flight, or at least long enough for the air supply to run out. So with the helicopter suspended from a bearing mounted string, it's time to see if this thing is going to fly. Aside from the air supply tube pulling the helicopter around, it's actually looking a little promising. So let's attach a one-way inlet valve to fill the bottle and see if it can run on its own air. And without the safety tether? It seems the nose of the helicopter pitches up very violently as soon as it takes off, which throws the stabiliser bar way out because it's only restricted to about 30 degrees of tilt.